What's going on, everybody? It's Mr. Gustin. Still not in the physics classroom, but I am right outside the physics classroom. It's right behind my wall right here. And we're talking about types or ways of charging. We talked about conservation of charge, meaning charges don't go anywhere. They're not created or destroyed. I'm sorry, they go somewhere. They're not created or destroyed, but they do move between objects when things get charged. Now, we've got a few different ways, 3, 4, however you want to organize these things, different ways they charge. So today, we're going to talk about ways of charging and how we can use those ways of charging, the differences, the definitions, that kind of stuff, and maybe even some models of it. Okay, so I've got 3 main categories. We have friction, charging by friction, charging by contact, and charging by conduction, and charging by, not conduction, oh my goodness, I'm doing my brain, this is silly, not conduction, it's charging by induction. You ever do that where you're thinking while you're writing and then you end up writing the wrong word? Charging by induction, my bad. So friction, contact, induction, and then induction, there are 2 kinds. There's induction by grounding and induction with polarization. Let's start with friction. I've got an example for you. With friction is where I'm going to take 2 objects that have different properties and I will rub them together. Rubbing, this is like the balloon in your hair type example. This is wool and PVC. If I rub them together, I'm going to transfer electrons from one object to the next object. Now, I won't exactly know off the top of my head which one is going to take electrons from the other one. I just know that when I do this, there's a transfer of charge. We can actually look up these things using what's called the triboelectric series, and that tells me which object is going to steal electrons more likely. In fact, there's an entire study of friction and how that thing works in the study of friction. It's called tribology. Triboelectric series means friction and electricity. So let's do an example of this, right? One example of charging would be, and this is going to be a little bit tricky to see. I'm not sure if we can see it on here, but if I go ahead and I charge up the PVC here by friction, this is friction sliding material. If I get this close to the camera, you might be able to see these little hairs on the, oh, you see it moving there? It's moving as I move. There it is, moving, moving, moving. The reason those little hairs on the wool are moving are because I rubbed the PVC, charging these 2 objects, and as I separate these 2 objects, they're going to have an attraction between them because I'm taking electrons from one, making it negative, leaving the other one with this positive charge on it. Let's go ahead and model it. Let's imagine I have this rod, and that rod is neutral. And I've got the wool, and the wool is neutral. Negative, positive. I like to distribute my charges evenly, that way they kind of show balance. So when I do this, this is before contact, then I rub them together, and as I rub them together and pull them apart, that rubbing is me taking electrons from one object, in this case it's the wool, to the other object. And that friction is pulling those electrons over, and as that happens, we end up with a negatively charged rod, like partially negatively charged, and a partially positive charged wool. And so when you have this difference in charge is what causes those hairs to stick up. This is how we model friction. This is charging by friction. Now, the friction, modeling by friction will be something we use to begin a lot of our demonstrations. So the next thing we have is charging by contact. Now, charging by contact, I'm going to show you this. This is a pith ball. A pith ball is just a light styrofoam ball attached to a light string. I'm going to show you how this object might get charged by contact. So first thing I'm going to do, I'm going to go. So we're charging by contact. Sorry for the skip. I messed up. I messed up, okay? So charging by contact. We're going to start by charging this rod by friction first, okay? So we're going to charge this thing up, get this thing really negative. You can actually kind of hear the static electricity transfer there. Then I'm going to take my relatively light metallic pith ball and I'll bring it near the rod. And if you see, it starts to sway. There's an attraction there. Did you see that? It touched and then fired off. It didn't stay attracted. As soon as it touched, check this out. Now it is repelled. This is because, and it's actually repelled in kind of a circular way, right? Look how far I can push that thing around, right? It is so repulsive right now. Now, what this is we have charged it by contact. What we had here was a neutral pith ball, positive and negative charges. We brought near it a negatively charged rod, the PVC. As soon as they touched, as soon as this came in contact with that rod, in order to balance the charges between the two things, the overloaded electrons here move, because electrons move, into this pith ball. Now we could also do our conservation of charge to figure out exactly how much charge moved over here, but my guess is if there's a net charge of -4 and two objects, it's probably -2. So we end up finally, afterwards, having the original particles in the pith ball plus the additional 2 electrons. If this rod is still somewhat negatively charged, the overall charge on this pith ball, or the metallic ball, is also negative. If this object is negative and this object is negative, what we're going to see? We're going to see that repulsive force. This thing's going to force this way. This thing's going to force this way. It's a third law pair, but we now see a pushing apart. This type of charging, when two objects come into contact to equilibrate charge, we call that charging by contact. Now, in terms of charging by grounding or charging by induction, induction is a word that looks like induce. Induce means to temporarily create something, temporarily make something happen. So we're going to go back to our PVC pipe now and our wool, okay? I also have a soda can here. Soda can is a very good conductor of electricity since it's made of metal. Let's go ahead and look right here, okay? If we have this set up, I'm going to go ahead and charge the PVC, so charging by friction. When I do this, I have a negatively charged PVC pipe, and if I bring this PVC pipe close to the can, what we start to see is the can is attracted. Are you seeing this? It's not like it's not a level table. It is level, but I am bringing this can closer and closer. I'm able to control how this can moves, right? This is charging by induction or polarization. Let's model what is happening here. Like, why in the world is this happening? Well, if we go ahead and look at what happens, I have this negatively charged rod. I did that by friction. I have this can right here. Let's go side view of the can. And the can is normally evenly distributed with charge. Well, as I bring that negative rod towards this conductive material, these electrons say, see ya, and get the heck out of town. They move as far away through that metallic conductor, through the sea of electrons, they flow as far away as possible. What this ends up doing is polarizing this object, where I get a positive end to this object and a negative end to this object. It doesn't actually cause the object to become not neutral. It's still neutral, but because of this, the positive side of this can is attracted to the negative rod we charge. So we see an attractive force right here, and that causes that can to start to roll. And as that can rolls, it continues to be attracted. If it happened to touch, we'd end up with this contact transfer of charge, and we'd see a quick repulsion. Now, it doesn't work very well with the insulating PVC. I tried it, but that's what we would see, right? If they did touch in a perfect world, as soon as they touched, we'd see a transfer of charge, and then boom, a repulsion. Now, the last one that we will see, the last thing that we will see is known as polarization. This one is hard for me to demonstrate grounding. It's harder for me to demonstrate, actually, but we're going to try just kind of show it, all right? So this is charging by grounding. Here's the deal. I have got this rod right here. I'm going to go ahead and charge it up. Let's charge it up. And after it's charged, I'm going to bring it near this can. Now we can see this can, it might start to move, I don't know. But this is negatively charged rod, a neutral can. So what I'm going to do here is I'm going to go ahead and touch my can, transferring the electrons into the can. No, this is stupid, hang on. We're going to try one more. This last one is going to be charging by grounding. Let me show you what this looks like. So we're going to go back to the friction on the PVC pipe and the pith ball. So let's go here. But watch this. Ready? Watch this. Ready? No, stay there. You got to stay there. It's locked. It's locked. Watch. And then it stays away. You see that? It's like magnets. But now watch. Ah, oh, shoot. I need a third hand. Wait, hang on. You see that? If I touch it, it stops being charged. If I touch it, the charge goes away, and then it touches again, and then it repels again. This isn't charging by grounding. We got to model it first, then I'll let you in, okay? We got to model it for ground. Do you have class right now or lunch? Okay. Let me model it first, and then I'll talk to some former students. All right, grounding. With grounding, what we saw was the pith ball was negatively charged, right? Positive, negative, negative, negative. And then this rod here, negatively charged. Now, I had a hold of my teeth. That was kind of gross. But as soon as I touched this with my hand, guys, can't you tell that's a hand? That's my hand touching it, right? Like that's what that is. As soon as I touched it with my hand, these charges, electrons, flow down my neutral hand. I'm grounding the electrons there, returning this object to neutral. Once it is neutral, and this is my negative rod, this is going to then be attracted back to the negatively charged rod. So they will make contact, negative and neutral. And then again, once they make contact, they return back to the way it was. And every time I go ahead and ground this thing, it swings back, it touches, then we have charging by contact, and it swings aside. Folks, these are the 4 basic ways that we charge things in our physics classroom. If you have questions, you drop in the comments, you send me an email, or as always, you can ask me in class. Until next time, see ya.